Hello, and welcome to today's session on quasi-experimental designs. Before we get started, as always, please make sure that you have the PowerPoint lecture notes printed in front of you so that you can make notes along the way. Today, before we get into our conversation on quasi-experimental designs, we're going to set up a contrast. We're going to remind you of some of the critical features of true experiments. This way, when we get to quasi-experimental designs, which we also sometimes call pseudo-experimental designs, the difference will seem really quite apparent to you. Furthermore, to help us set the stage for today, let's just recall our research cycle, where we typically have a real-world phenomena that we're interested in. As psychologists, this will be some kind of behavior, thought, or feeling. We will engage in some kind of abstraction to create a manageable research representation. You might recall that abstraction typically has two components. First, we have operational definitions, where we state the operations by which we're measuring our variables. And then also we have our sampling, and we have many different kinds of sampling techniques. This combination will give us a usable, achievable research representation, something that is manageable and will allow us to use many different kinds of methodologies to generate research results. To refresh your memory, this semester we've been talking about three different kinds of methodologies. We talked about survey methods, we talked about observational methods. Today we're going to be talking about a variation on experimental methods. That would be the third variety that we'll call quasi-experimental designs. And these two can help us come out with some kinds of results that we can analyze using either descriptive statistics or inferential statistics to give us some kind of research conclusion that we hope can be generalized back to the real world. So let's begin by emphasizing what it is that makes a true experiment a true experiment. And first we'll talk about three different features that will all bring us to this notion that a true experiment is one that unambiguously demonstrates what caused an outcome. That's really what a true experiment does. And we'll spend a little bit of time talking about these three features that get us to this kind of a conclusion. First, we have the manipulation of an independent variable. We might have more than one independent variable, but most of us remember, even from Intro to Psychology, that having an independent variable that is manipulated is critical to having an experiment. Remember that the independent variable is the variable whose effect we seek to know. So we're going to now have a manipulated independent variable, and I'm going to give you an example of two different operationalizations of the same construct. One will be manipulable, the other one will be purely observed. It's not manipulable. That construct will be the variable of gender. And we can think of gender lots of different ways. But traditionally, we think about gender as being male and female, having those two levels of the variable. Let's say that we're political psychologists, and we're interested in knowing how a particular political candidate might be perceived by male voters and female voters. Now, male and female voters will be that will be a type of classification, a way of dichotomizing the electorate in such a way that we're not manipulating. We're not in any way assigning somebody to be male or female. Before these folks come into our study, they have a pre-existing identity as either being male or female. This is not something that we're manipulating. It might be a very interesting question as to whether there are gender differences in the perception of a particular political candidate, but this is not something that you and I are directly manipulating. So here we have an independent variable, a variable whose effect we seek to know, but it's not a manipulated variable. Let's take that same variable, gender, and now we'll see if we can do another kind of political psychology experiment, but this time around we will manipulate the gender variable. We'll keep the exact same two levels of the gender variable, male and female, but now what we'll do is we will randomly assign the name of our little write-up that we might have in our study of our candidate as being either a male name or a female name. A frequently used manipulation here is the difference between the name John, which is traditionally understood to be a male name in American English, and Joan, which is typically understood to be a female name in American English. And we can have a paragraph that gives all kinds of descriptions about a particular candidate, and we can have one version of this paragraph that contains references to John. And then we can have another version of that that contains references to Joan. All the descriptions remain letter for letter identical across these two different conditions, except for the swapping out of John for Joan, Joan for John. Now we've manipulated the gender variable. We have a directly manipulated independent variable here, and this will give us at least a shot at having a true experiment. Okay, let's go on to another one of the criteria for having a true experiment, and this is that we have to have a high level of control. We have to have some way of distinguishing what we might call a treatment group or a treatment condition from either a control group or a control condition. Sometimes we can even have two different experimental groups. They're both getting a direct treatment from us, and we might use one group as a control for the other. But what characterizes true experiments is a high level of control. Frequently we try to maximize the similarity across conditions except for the independent variable, which of course we're manipulating. And that might be the sole factor that distinguishes the treatment group from the placebo group or the control group. Okay, lastly, a true experiment will have random assignment to conditions. And this can be random assignment to different groups if we have an independent samples design, also called a between subject design, or we can have random assignment to different conditions if we have a within subject design. But in any case, random assignment is going to be very, very critical. And the reason for this is that if we have random assignment, we can be confident that our outcome might not be attributable to pre-existing differences between the groups. We never really know if we're using pre-existing groups if there are relevant differences between those groups. It might be that there are differences in socioeconomic status or education level. There might be geographic differences. There might be some age differences. If we use random assignment, we can be confident that at least across a large number of randomly assigned participants, we've leveled out the differences across the two different groups, and we have now really the isolation of the independent variable that will allow us to get to this promised land, a true experiment unambiguously demonstrating what causes an outcome. Okay? Now, what we'll see in just a few minutes is a quasi-experimental design, or a pseudo-experimental design, and usually the feature that's missing in those cases is random assignment. Sometimes in the real world we're relegated to having to use a pre-existing group for very practical reasons, and so we're going to contrast one group with another group even though we didn't use random assignment. That's going to be the most frequently observed difference between true experiments and quasi-experimental designs. Okay, let's see if we can now just refresh your memory with some related ideas on these topics. And we'll give you now two pop quiz questions. I'll read both of them, and then after reading each of these, we'll ask you to reflect on them after you've stopped the video. First, let me read them to you. So in your own words, how does the setting, that is the laboratory setting versus the field setting, relate to the issue of validity? And remember that validity is taking two different flavors here, so to speak, internal validity versus external validity. That's our first question. The second potential pop quiz question is, again in your own words, how does the setting, lab versus field, relate to the goals of research, basic research versus applied research? So we'll have you stop the video and answer these two questions now. Okay, welcome back. Let's take a look at your response to the first question, and we'll think about it this way. Remember that we have laboratory settings and we have field settings. It turns out that laboratory settings are particularly good for flushing out internal validity, or for establishing internal validity. That is to say that frequently it's the case that we really want to understand whether we're measuring exactly what we're measuring. And remember that when we're trying to draw a causal inference, we have to establish three criteria. From several lectures ago, you might remember that first we have to establish correlation. Correlation by itself is not sufficient for causation, but it is a necessary condition. Additionally, we have to establish a time-order relationship. The cause has to precede the effect, and it's not always the case in observational studies that we can be sure about what is causing what is preceding what. Sometimes the two variables appear to be co-varying in time, and we need to make sure that we have the direction of causation unambiguously established. The third factor for a causal inference is that we have to be able to eliminate plausible alternative explanations. And what's beautiful about the laboratory environment is that we can control all conditions and systematically manipulate just one variable at a time. This then allows us to maximize internal validity. Are we measuring what we want to measure? That's what internal validity is. Now, the downside of the laboratory is because everything is so beautifully controlled, we have some mismatch between the way the laboratory is operating and the way that the real world is operating. The real world is now fluctuating with all different kinds of variables going on simultaneously, sometimes going on in an almost random manner that we wouldn't see in the laboratory. So our capacity to generalize outside of the laboratory finding to the real world is somewhat limited. So for this reason, we say that external validity is relatively low in laboratory settings. We get the complementary set of pros and cons if we look at field studies. In the field studies, we get a lot of external validity because we're in the setting where we typically want to see the phenomena of interest, and so the typically occurring variables that might be fluctuating somewhat randomly over time are occurring during our field observation or during our field experiment. And if we still find our effect under those conditions, we can be relatively confident that in the future we could perform that manipulation again and our manipulation would continue to work. Okay? By contrast, though, we can't always be quite so sure about whether we're really measuring what we want to measure when we're in the field. So the internal validity is going to be lower. We don't have as much control over field settings, obviously, as we do over laboratory settings. So I hope that helps you reflect on question number 1. Let's go to pop quiz question number 2, which again was, in your own words, how does a setting, again lab versus field setting, relate to the goals of research defined here as basic research versus applied research. So in basic research, we're conducting research for knowledge's sake. We're trying to derive knowledge for knowledge's sake, and here we're very often trying to understand fundamental principles about the phenomena of interest. Maybe fundamental principles about how sensations work, fundamental principles about how pharmacology works or how memory works. These are the kinds of questions that we might be interested in if we're engaged in basic research, and laboratory settings are ideal for this because we can draw such strong causal relationships here, even if it's the case that we can't generalize. On the other hand, it's often the case that we don't have much applied success inside of the laboratory. Sometimes things work quite well inside of the laboratory, and then we bring them out into the field, and they're not working quite so well. So the field settings are sometimes desired for getting to applied research. Applied research, again, as you might remember, is research that's designed to solve an everyday problem, a real-world problem. So the field setting is ideal for that. The laboratory setting is better for basic research when we're trying to derive knowledge for knowledge's sake. Okay, let's go on to look at a couple of other kinds of pop quiz questions that will move us into the distinction between quasi-experimental designs and experimental designs. First, let's take a look at a relatively famous study in psychology called the Hawthorne Effect. And we'll ask you to go out to this wiki page. You can copy and paste this out in wiki and read a little bit about the Hawthorne Effect and then see if you can summarize it in your own words. Before you do that, though, we'll also give you another pop quiz question. In your own words, explain what is meant by contamination within the context of problems of even true experiments. How does contamination work its way into experiments? So we'll have you respond to these two questions, and you can stop the video now. Okay, welcome back. Let's talk about this corporation called Hawthorne Works, which was outside of Chicago. It was a Western electric company, and this study was done back in the 1920s, maybe 1930s as well. One of the well-known studies from the psychology history. And what we can say about the Hawthorne effect is it's very much like what we might call the observer effect. We're going to see in the Hawthorne effect that there is a change in behavior that arises simply because the participants know that they're being observed. You might remember that in earlier videos we talked about this as the issue of reactivity, the change in behavior that occurs when the participant knows he or she is being watched or being observed. Okay, so in the Hawthorne effect, initially what was going on was we were looking at a baseline level of productivity for workers who were in a factory setting. So this is very much a real-world setting, a field experiment. And the manipulation that went on out in the field was a simple illumination manipulation. They simply changed the level of light, and they raised the level of lights, and they wanted to see what happened to worker productivity. So they raised the light level, and productivity came up. They did it again. They raised the light level one more time, and productivity came up. They raised the level another time, productivity came up. Now here's something very interesting. Now they lowered the level of light, and productivity went up again. So what was interesting was it wasn't as if there was a direct relationship between the illumination level and the productivity level, but rather what it appeared to be to the researchers was that as long as you could demonstrate to the workers on the factory floor that management was very interested in them, the workers were inclined to comply. This was a demonstration, among other things, of reactivity. That is, that if you know that you're being watched, you might change your behavior in a way that you think makes yourself look good, or maybe in a way that you think matches what the researcher is expecting to find. So this is an important issue out in the field, and as we'll see in the moments to come, this was an example of not only a field study, but also of a quasi-experimental design. We didn't use random assignment in the Hawthorne effect, in the classic Hawthorne case. Okay, let's see if we can now build on that and come to the second question of explaining what is meant by the word contamination within the context of experiments. We can think of contamination as the communication of information between people who are in an experiment in different groups within that experiment. So we're having members of one group communicate information about the experiment to members of another group. And this is a leaking of information between these groups that we might have hoped had remained relatively independent of each other. And when we have this leakage, or this contamination, this sharing of information about the experiment between groups in the experiment, lots of funny things start happening. And we're going to take a look at some of these here in the next series of pop quiz questions. Okay, so let's take this as a three-part pop quiz question, and we'll remind ourselves that contamination, this sharing of information, sometimes can generate resentment or demoralization in the control group. It can sometimes generate a rivalry between the groups. It can sometimes be described simply as diffusion, or the sharing of information between these groups. So let's see if we can now take these three different possibilities and link it to an important concept that we learned about earlier this semester. This is the distinction between a type 1 error and a type 2 error. Remember that a type 1 error is a false positive. This occurs when there really is no effect for our manipulation, but we falsely believe that there is an effect. Conversely, we can have a type 2 error, which is also known as a false negative, and the false negative arises when there's actually no effect of our manipulation, but we falsely assume that there actually is an effect of our manipulation, and we falsely assume that there isn't. We have a miss, essentially. So we can have a false alarm, that's a type 1, or we can have a miss, that's type 2. Okay, let's see if we can now unpack that in these three questions, A, B, and C. In question A, we'll ask you, does resentment demoralization tend to increase type 1 error or type 2 error? Which of those two is more likely once we have a demoralized or resentful control group? Okay, we'll give you a moment to respond to that in just a moment. Then we'll ask about rivalry. Does rivalry tend to increase type 1 error or type 2 error? Okay, and we'll ask you to explain your answer to that. And then finally, does diffusion tend to increase type 1 error or type 2 error? And your explanation for that will also be needed. So we'll have you stop the video now and respond to these questions. Okay, welcome back. Why don't we take these one at a time? Remember that the issue here is contamination, the sharing of information about the experiment between the groups in the experiment. Okay? And to help develop this idea, I'm going to harken back to an issue that I raised once before in this video series. I talked about a simple experiment inside of Intro to Psych, where we're talking about the issue of memory. And we're trying to demonstrate to the Intro to Psych students that separate from what they usually do, and differently from what they usually do when they're trying to memorize information using a mere rote procedure, they can use any number of mnemonic devices, memory tricks. And one of them is a simple naming scheme, where we can create names associated with the numbers of the items that we're asked to remember, and we might use a rhyming here. So you can think of the numbers 1, 2, 3, 4, 5 as having simple rhymes, something like bun, shoe, tree, door, hive. So each of those words can be thought of in a very exaggerated way using mental imagery. And you might be given, for example, 5 items to remember on a list. And you might think of taking the very first item on the list and putting on a gigantic bun. Bun is for 1. And then you might think of the second item on your list and putting it inside of this gigantic brown shoe. 2 is for shoe. And then you can think of the third item on the list as dangling from an imaginary tree. 3 is for tree. And then you can think about the home in which you were raised and the front door. You probably have a good, vivid imagination of what that is. Door is for 4. We can take the fourth object on the list and slam that up against your door. And then finally, we can have a very large imaginary beehive, and we can take the 5th item on the list, that's number 5, and we put it on hive. So now we have a very simple way of enumerating these items and tying them back to a visual memory. This is usually a much more successful trick for memorizing items than would be the case of just using rote memorization. So we can assign half of our students maybe to using the rote memorization, half of them are going to be using this rhyming scheme, this memory trick. Okay, now let's say that we have some contamination, that we have some sharing of information between the two groups. Maybe we have roommates who have been assigned to different conditions, and unbeknownst to us, the roommates are texting each other, or the roommates are communicating in some way with one another. And so one of the roommates, who we thought was in the rote condition, is actually now being, now essentially in our other condition, our rhyming condition, because they're using the rhyming tricks that they've learned from their roommate. Okay? All right, so what happens here? There might be some resentment or some demoralization. It might be the case that the folks who are in the rote group know that the other group has something good, and they're kind of down about this. They're feeling demoralized, they're feeling resentful, and they give up. Okay, so now what might happen is that we see the emergence of a type 1 issue. We might have a type 1 error. It might be the case that really our new memory trick does nothing, but because the control group has become demoralized or resentful, they perform less well than they otherwise would. Maybe they're not trying very hard. They're demotivated, they're demoralized. So maybe we actually had no effect, but we think we see an effect there of our memory trick simply because the group has become demoralized. So now we have a false positive. So the probability here of the effect of contamination, if it takes the form of resentment and demoralization in the control group, we might get a type 1 error, interestingly enough. Okay? That's not the only possibility. We could have contamination generating a rivalry between the groups. It might be that one of the groups, maybe the rote group, doesn't want to look bad. They want to look just as good as that fancy rhyming group. So now they work really, really hard to make sure that their performance is just as good as that of the other group. So it might be the case that we actually did have a true and genuine significant effect such that the folks who are in our rhyming scheme condition would normally do better, but the folks who are over here, they don't want to look bad, and so they try really, really hard. They put forth a Herculean effort, and they actually catch up to the other group. So now we see no difference between the groups, but there really would have been a difference had there not been contamination. So now we're going to wind up with a type 2 error. We're winding up with a false miss, or I should say we have a miss, which is now a type 2 error, and this is arising again because of contamination, in this case taking the form of rivalry. Okay, let's go on to our last case, diffusion. This is what I alluded to earlier, and now it might be the case that we think we have a rhyming group, we think we have a rote group, but actually everybody's using the rhyme, okay, because maybe people find out that the rhyme is very effective. So there really would be an effect for the rhyme, but because of this contamination, we have some diffusion going on, and the rote group is using the rhyming scheme. Their behavior comes up to that of the other group, and now we actually wind up with no apparent difference between the groups, even though there really should be a difference. So this would, again, be a type 2 error. So to summarize, we had type 1, type 2, and type 2, all arising because of contamination. An interesting idea. Okay, why don't we have you stop the video at this point and jot down to this point what has been clear and what has been less clear. Okay, let's see if we can now proceed and talk just a little bit about quasi-experimental designs. The very first design that we show here is done so schematically, and we're inspired here by Campbell and Stanley's early work in the 1960s or mid-1960s, and we're asking basically what's wrong with this picture. I will walk you through this one just so you understand what the symbols mean in this particular case. The O here is actually a letter O, it's not the number 0. This is observation at time 1, and then we're going to have some treatment that's symbolized here at a subsequent time by this X, and then we're going to make a second observation of behavior. And what we might do is, for example, have an interest in educational psychology. And we want to see if we can raise mathematical test scores from time 1 to time 2 by having some kind of intervention. Maybe we've got some high school seniors or maybe even some first-year college students, and our treatment might be something like giving our students a review of the algebra that they had learned, the geometry that they had learned, the trigonometry that they had learned, the calculus that they had learned. Those 4 years might be summarized by some kind of treatment intervention, and we'll see if we can increase scores from time 1 to time 2. What's wrong with this picture? Okay? From an experimental point of view, something might be very obviously wrong, and we would call this the pretest post-test effect. That is to say that if we had given a test at time 1 and we had taken our observation, and then we engaged in some manipulation, maybe some kind of review of their high school mathematics, and then we take another observation at time 2. We might fool ourselves into thinking that any improvement that we see at time 2 is actually attributable to our intervention. There are alternate possibilities that are very plausible in this case. One alternate possibility that's very plausible is that it might just be the case that at time 2, the students had learned how to manage their time more effectively. It might be, for example, that we give them 30 minutes to complete a relatively standard math test. And it might be that they learned that they had mismanaged their time back here at time 1. So at time 2, they're managing their time more effectively, even though they really don't understand algebra or geometry or trigonometry or calculus any better at time 2 than they did at time 1. They just became more effective test takers. Their math skills really weren't any better. So how would we know? How would we know whether they were really better at time 2 because of an improvement in math skills versus some other kind of artifact? Well, what we can do is go on to some kind of design that's a little bit more elaborate and that can control for this alternate possibility. Here, we do the same thing that we had a moment ago for one group, but we now also exact some kind of control. Remember that we had 3 different criteria for true experiments. We have to have a manipulated variable, which we did have in our earlier diagram. We also have to have appropriate kinds of controls. We have to have some kind of comparison group. And here we get the comparison group. What's interesting about the comparison group is they too are observed on their math skills at time 1 and at time 2, but they don't have the intervention. Now what we would hope for is to see that this particular group is not performing as well as this group. And if there are group differences here, then we might be more confident in drawing the conclusion that our manipulation is actually working. So you can see the importance of exacting some kind of control by having some kind of relevant comparison group. In this case, it would help us eliminate this pretest post-test effect. Okay, let's see if we can go on to other kinds of research designs that are going to be quasi-experimental. And we're going to consider 3 different varieties of quasi-experimental designs. All of them are going to lack randomization. So we're not going to have a true experiment, but still we'll have something that approximates this, something that is, if you will, as the name suggests, quasi-experimental, almost an experiment, okay, but in all cases lacking the randomization. The first of the 3 that we're going to be talking about is called the non-equivalent control group design. And here, a group that is like the treatment group can be examined pre-test and post-test. So this might not be a randomly assigned control group as we might have had back over here. Actually, in this design, we are not entirely clear about whether these 2 groups are pre-existing and maybe similar to each other, or whether we can be confident that they're actually identical to each other, statistically speaking, through random assignment. So we'll have some kind of non-equivalent control group where we don't have random assignment working. And we'll see if we can give some kind of a pretest to ensure at least some meaningful similarity. So what we'll have you do is see if you can understand a real-world application of this kind of design called the non-equivalent control group design by taking advantage of this wiki link, or excuse me, this PubMed link. You can copy and paste this into your browser and read a little bit about this study by Langer and Rodin in 1976, where they were looking at how it is that people age and how their facilities, their mental capacities change over time when they're in a nursing home. And they have very much a design akin to this, the non-equivalent control group design. So we'll give you a moment to stop the video and copy and paste this into your browser and read that abstract and see what you can surmise about this particular quasi-experimental design. Okay, welcome back. I hope you found that to be interesting, and I hope you can begin to tie this back to the first of our 3 designs, non-equivalent control group design. Rather than my elaborating on this particular design here, we'll see what you have to say about that in the classroom. We might even make this a potential pop quiz question. We might ask you to write out a few sentences about what went on in this particular study and how it's relevant to this. Okay? We'll be looking for some specifics to indicate that you had done the reading appropriately. Okay, why don't we go on and talk about the second of our 3 quasi-experimental designs. This is called an interrupted time series, and this is used when researchers have the opportunity to observe the dependent variable for a considerable time before and after the treatment is imparted. And this can be schematized in the following way. Here we have observations, but unlike what we had seen previously, we now have multiple observations. Observation at time 1, at time 2, at time 3, and then after multiple observations, we impart our manipulated variable or some kind of change to the environment, and then we look for a sustained period of time at the behavior at times 4, 5, and 6 in this hypothetical. Okay, so that's what the O's and X's mean. Again, the O's are for observational times and the X is for the treatment. And we'll see how this might play out in the real world. In the 1950s, there was a movement to see if we could change driving behavior. Okay, and now we can't necessarily assign people to different kinds of groups. We're going to be lacking random assignment, but we can ask about the effectiveness of a particular manipulation. So what we want to do here is first measure in the early 1950s the number of suspensions for speeding. This would be driver's license suspensions for speeding as a fraction of the total number of suspensions. Okay, so that's the behavior that we're indexing, and we're getting multiple observations across the early 1950s. Then the governor wanted to impose what he had called a crackdown, and that is that he wanted to see if he could change driving behavior. The first step there was to see if he could get the police officers to actually enforce speeding-related tickets more effectively, and that would result in then a higher number of suspensions that are related directly to speeding, having your driver's license suspended for speeding. And you could see that once the crackdown was exacted, we now have a rather dramatic increase in the number of license and suspensions that are speeding related, and that was sustained for some period of time. So whether this actually went on to affect driving safety would require more data still, but at least we know that the governor had exacted a law, and it seems to have been taken up by those who enforced the law when we look at the dramatically high levels of suspensions after the crackdown versus those before the crackdown. Okay? So we don't really have a randomly assigned control group, but if you look at the pattern of data, and you look at the pattern of data critically, across multiple observational periods before and after the onset of the manipulation, then we can draw a moderately confident conclusion that there's probably a causal relationship between these. Strictly speaking, we probably can't say that there's a causal relationship here, but we have at least a plausible candidate for a causal relation given the pattern of results here in our interrupted time series. Okay? Okay, now what we can do is we can combine these two kinds of ideas, the time series with the non-equivalent control group design, and see that this combination can also be very powerful. This is used when researchers have the opportunity to observe the dependent variable for considerable time periods before and after the treatment, and also when we have a control condition of sorts. And this next slide is going to be a little bit busy, so we'll take a moment walking through the different steps. Okay, first, let's get it schematically. Here you can see something similar to the earlier schematics that we had in this presentation. We're getting multiple observations at time 1, 2, and 3. We'll call these observations before we exact some kind of manipulation, and then we'll have multiple observations after that manipulation. Interestingly though, we're going to, in this particular case, because we're combining these two quasi-experimental designs, only one of our two conditions is going to be exposed to the manipulation, the other one will not. So what we hope to see then is a relatively stable line of performance for these two conditions, and then after the manipulation, one group takes off and the other group does not, or one condition takes off and the other group does not. This would be relatively persuasive evidence, particularly if the observations are occurring for these two conditions across the same time period. Okay, let's take a look at how this might be implemented. And this is a little bit busy, so I'm going to try to walk you through and ask for your attention very closely as we're walking through here. We're going to look at how it is that people use telephones, or how they used telephones, past tense, from the interval of 1962 to 1976. And we're going to take a very applied approach here, and we're going to think about how the phone company might have been interested in this behavior. Specifically, the behaviors of interest are going to be local directory assistance calls and long-distance directory assistance calls. So just to set the stage a little bit for that, you might know that back before we had the internet, we had frequently people using phone books to find out the telephone numbers of the folks they wanted to speak to. And it was the case that if you were in a town like Columbus, Ohio, it would be very easy for you to walk into what was then a phone booth and use the phone directory that was right there. And you could look up somebody's telephone number and you could dial that directly. Alternatively, rather than using the phone book that was right in front of you, you could have just picked up the phone and dialed for local directory assistance. And you could have asked for that phone number for the local call. You can also, of course, ask for the telephone number of somebody who's located in a very distant city, maybe something like Las Vegas. Okay, so if you're in Columbus, Ohio, you wouldn't have ready access to a Las Vegas telephone book, but you would have access to a Columbus telephone book. Okay, so you can always bail out and just call the operator and ask for assistance. The problem with that, from the phone company's perspective, is that's a very expensive service to provide. And it's understandable that you couldn't stock every single phone booth, with phone books from around the country. You can only stock the phone booth with a very local phone book. So what the phone company wanted to do then was somehow reduce its costs. And what it said was, we're going to still provide for you the service of long-distance directory assistance, but we're going to try to now get to change your behavior. We're going to try to get you to refrain from calling the directory assistance folks for local calls, because you could be using the phone book there. Okay, so with that set up, let's now take a look at how we have on the x-axis the years from 1962 to 1976, and here we have the number of calls per average business day to the directory assistance folks. And we're going to have two different conditions here. We're going to have long-distance directory assistance shown in these solid circles, and then the local directory assistance shown in the open circles. And what you can see is that over time, there's an inclination for people to make local directory assistance calls much more frequently than long-distance directory assistance calls. And what the phone company said is, we're going to try to change that behavior. We're going to try to decrease this costly behavior of local directory assistance calls. So they applied to the FCC, the Federal Communication Commission, and they asked for permission to exact a charge, in this case a 20-cent charge, which would have been something non-trivial back in 1974 for getting local directory assistance. And in 1974, they now turn on their intervention, and they begin to charge you for local directory assistance calls. And you can see there's now a complete reversal. These open circles, which were very frequent or high on the ordinate or y-axis, now are all the way down here. We've actually deterred that behavior by having this kind of charge implemented in 1974. You might notice that there's almost no change in the control condition, which in this case would be the long-distance directory assistance. Okay. Here's another variation on that. I think you'll find that in this particular case, you'll see that we have a quasi-experimental design. We really don't have the levels of control that we would typically want to have. We don't have random assignment, but you can now selectively turn a behavior or a treatment on or off and look at behavioral changes. So in this particular case, we're looking at burglaries in a neighborhood that's plagued by burglaries across an 80-day interval. And typically we have police cars that are out on patrol, and those have some effect, but they're not particularly effective, at least when we compare it to our intervention. Our intervention is going to be a helicopter patrol. And from this elevated position, you can look down on this troubled neighborhood that's plagued by lots of burglaries, and you can probably catch the burglars much more easily. And the burglars know that, so their behavior is probably deterred when the helicopter is floating around by patrol overhead. So we first have this initial observation period over the first 20 days when we have the car patrol only. And then we add to the car patrol the helicopter patrol, and you can see that generally speaking there is a decline in the number of burglaries. Then we go back for some interval of time to car patrol only, and you see that the number of burglaries inches back up, and then we turn the helicopter back on in conjunction with the patrol, and hopefully you'll see that we get early on a decline in that interval of the number of burglaries, and then we take the helicopter away, and we have the car patrol only, and back come the bad guys again and their bad behavior. Okay, so we can see that there's probably some effectiveness of this helicopter by looking at the time series and observing the differences in burglaries in this particular case in the presence and the absence over time, systematically manipulated, of this helicopter patrol. Okay. So that brings us to the end of today's presentation, where we've talked a little bit about quasi-experimental designs and how they're different from true experiments. As always, we'll ask you to write down what has been very clear about this. That helps you with your metacognition, and also to write down what is less clear and to bring those issues into class. See you in class.